All right, so these are the notes for loan calculations and regressions. Don't worry about those objectives up there. I think there was a misprint in the financial algebra book. Our real objectives, we're going to calculate interest that you're going to pay over the life of the loan. We're going to figure out how long a loan needs to be, given some information, like you can only afford to pay so much in your budget, how long should the loan be for. And then we're going to look at how to read a loan table, which is a little different than the monthly payment table that we looked at last section. So we'll go over that in example 5. Okay. So let's start with our little fill in the blanks here. So before taking out a loan, you need a complete picture of what your payment responsibilities will be over the life of the loan. Part of your monthly payment decreases your principal, and part is the finance charge. Or interest. So your monthly payment makes up 2 parts. Part of what you pay goes towards principal, part of what you pay goes towards your finance charge. For a loan, interest is an amount of money that you have to give to the bank as a fee for using their money. There are many monthly payment calculators available on the internet. Monthly payment calculators available on the internet that can give you a summary of the loan balance over the lifetime of the loan. Loan balance over the lifetime of the loan, and on a monthly or yearly basis. So when we talk about the length of a loan, we often use the term lifetime, monthly or yearly basis. So like if you have a 15-year loan, then the lifetime of that loan is 15 years. So that's where that term comes in. You'll probably hear me say it a lot. So examine the summary statement of a loan calculator for a $100,000 loan with an APR of 7.5%. for a period of 15 years, taken out in January 2010. So that's this table here in the notes. Notice that the interest you must pay is more than half the amount that was borrowed. It says up here in the top of the table that your monthly payment is $927.01, and the total interest paid over the life of the loan is going to be $66,862.22. So one thing you'll notice when you look at the table is that you start off paying way more in interest than you do in principal. So you're paying off a heck of a lot more of the interest in the very beginning compared to almost twice as much compared to the principal. So notice as the months pass, the principal that is paid off by your monthly payment of $927.01 increases as the interest amount decreases. Pick any month. When you add the two numbers together, so say we look at June of 2010, if you add 311.57 and the 615.44, that's going to give you the total monthly payment of the $927.01. So pick any month, the sum of the principal paid and the interest paid will always be approximately equal to your monthly payment. But in the beginning of the loan, more goes to paying the bank interest than paying off the principal. So in the beginning, the bank is more interested in getting its payment back of the fee that you owe for using their money. And so what we're going to do for our first couple examples, we're going to be using the monthly payment formula that we learned in the last section. Let me write that out real quick just to remind you. M equals P times R over 12 times 1 plus R over 12 to the 12t, all divided by 1 plus R over 12 to the 12t minus 1. All right, so that's just the formula we used last section to figure out monthly payments. So example 1 says to determine the total interest owed on a 5-year loan at 6% APR. So there's going to be 3 parts to this. First, we want to figure out the monthly payment. Once we find the monthly payment, then we can figure out the total amount that we pay over the entire life of the loan. And then once we know that, we can figure out the interest that we pay. So let's start by finding our monthly payment. I left out the principal in my, there's a typo here. Our principal is $10,000. It was a $10,000 loan, 5 years at 6% APR. All right, so our principal is $10,000. Our interest rate is 6%, so as a decimal, that's 0.06 over 12. 1 plus 0.06 over 12 to the 12 times 5, because it's for 5 years, all divided by 1 plus 0.06 over 12, 12 times 5 power minus 1. So that's what we're going to plug into our handy-dandy calculator and hopefully not mess up while we do it. Let's see what we got. Okay. So we got $10,000, 0.06 over 12, 1 plus 0.06 over 12 to the 12 times 5, 1 plus 0.06 over 12 to the 12 times 5, 12 times 5, minus 1. All right, so $193.30, round that up to 33 cents. So that's his monthly payment. $193.33. All right, so now that we know the monthly payment, we're going to take that, figure out how many monthly payments he does in 5 years. So 5 years times 12 months in a year is 60 months. So the total paid is going to be the monthly payment times 60 months. And we get $11,599.80. All right, so that's how much we pay over the total life of the loan. So if we only took out a loan for $10,000, we can figure out what our interest was. So we're going to take our total paid, subtract off the principal. So $11,599.80 minus 10,000. And that's going to give us $1,599.80. So that's how much we pay total in interest on our loan. All right, example 2. Hannah is taking out a 4.3% loan to purchase an $18,000 car. The length of the loan is 8 years. How much will she pay in interest? All right, so we're going to do the same thing we did with the last example. Start by finding her monthly payment. So monthly payment is principal times, let's see, 4.3% as a decimal is going to be 0.043 over 12 times 1 plus r over 12 to the 12 times t, which is 8, all divided by, 1 plus 0.043 over 12 to the 12 times 8 minus 1. Alright, so let's plug that into our calculator. Alright, so we've got 18,000, 0.043 over 12, 1 plus 0.043 over 12 to the 12 times 8, and then 1 plus 0.043 over 12 to the 12 times 8 power, 12 times 8, not 1, 12 times 8 minus 1. And I got $222.90, round that up to 93 cents. So $221.93 is her monthly payment. All right, so now we need to figure out how much she pays total over the life of the loan. It's an 8-year loan, so how many months are in a year? There's 12, so 8 times 12, 96, so that's 96 months. So her total paid, again, we're going to take our monthly payment, which was $221.93, multiply it by 96 months. And we get 96 times 221.93 is $21,305.28. $21,305.28. All right, so the amount of interest that she pays is going to be whatever this amount is minus the original principal, which was $18,000. So interest paid going to be $21,305.28 minus 18,000. And we get $3,305.28. $3,305.28. And that's your total, your final answer. All right, so now we're going to figure out how to calculate how long a loan should be given how much we can pay. So for example, so this basically we're looking for the length of a loan. We use our monthly payment formula, but it gets rearranged and we solve for t. And doing that, we're going to it's going to bring in some natural logs into our formula. So our formula time is the natural log, which remember is just ln, and it's a button on your calculator. So the natural log of m over p minus the natural log of m over p minus r over 12 divided by 12 times the natural log of 1 plus r over 12. All right, so that's the formula we're going to use to figure out the length of a loan. Okay, so remember, T is time in years. M is monthly payment. P is principal. And R, interest rate. All right, so there's your formula. Example 3. It says, Claude wants to borrow $25,000 to purchase a car. After looking at his monthly budget, he realizes that all he can afford to pay per month is $300. The bank is offering a 5.9% loan. What would need to be the length of the loan so that he can stay within his budget? So basically, we're just going to plug stuff into our formula up here. So we know principal amount for the car, $25,000, so that's our P. We know his monthly payment that he can afford, $300 a month, so that's our M. And we know that the interest rate from the bank is 9.5%, which is 0.059 as a decimal. So we're going to plug that into our formula. So T is the natural log of 300 over 25,000 minus natural log 3 over 25,000 minus 0.059 over 12, all divided by 12 times the natural log 1 plus 0.059 over 12. All right, so that's what we're going to plug into our calculator. Now remember, natural log is this button right here, ln. All right, so we've got natural log of m over p, so 300 over 25,000 minus natural log of 300 over 25,000. Oops, I put in too many fraction bars. 25,000 minus 0.059 over 12. Close parentheses twice, otherwise it's going to give you an error message. Error down. 12 times the natural log of 1 plus 0.059 0.059 over 12. And I got 8.956, round that up to about 9 years. So T is approximately 8.96. So he needs about 9 years on the loan. So if he's got a 9-year loan or longer, then he's going to stay within his budget of $300 a month on his loan payment. All right, so example 4 says, in example 3, what impact would an increase in the monthly payment of $50 have to the length of the loan? So we're using the same information as from here. The only thing that's changing is our monthly payment. So again, we have a principal of $25,000. Our interest rate is 0.059, but we're going to raise how much we can pay each month by $50. So instead of $300, we're going to pay $350. And we're going to see what that does to the length of the loan. So, plug it into your formula. ln of 350 over 25,000, I mean, minus the natural log of 300 over 25,000 minus 0.059 over 12 over 12 natural log of 1 plus 0.059 over 12. All right, so that's what we're plugging into our formula, or into our calculator. Ooh. All right, so we got natural log of 350 over 25,000 minus natural log of 350. Oops, notice I put 300 there. It should be 350 over 25,000 minus 0.059 over 12, two parentheses, over 12 times the natural log of 1, oops, it should be 12, I just put 1, 12, oh no, I hate when I do that. Okay, I'm going to have to start over. Natural log 350, 2,500, 25,000 minus natural log 350, 25,000 minus 1.059 over 12, that should be a plus, and over 12, two closures, 12 times the natural log of 1 plus 0.059 over 12. Hopefully that gives us the right answer. No, it didn't. All right, one last time. Oh, it is minus. I put plus, that's why. Over 12. Oh, close parentheses twice. All right, hopefully this one works. 7.35, there we go. Third time's a charm. All right, 7.35. So you'll notice, by just paying $50 or more each month, it goes from a $9 or a 9-year loan to a 7.35-year loan. So it's cutting off a year and a half from the life of the loan just by paying $50 more each month. So it cuts about 1.5 years off the life of the loan. Example 5. Use the loan table to the right to answer the following questions. So before we answer questions, let's look at the table. We've got years down this column, the amount of principal that's paid for the entire year here, interest paid, or for, the entire year, sorry, and then the balance of the loan. And then it goes from 2018 to 2019 up here and continues on. So part A says, what is the loan amount? You'll notice top row right here, $76,000. So that's your loan balance. Part B, what is the length of the loan? Well, how many years do we have in our table? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 years. Part C says, what is the monthly payment? So what we're going to have to do for this, first of all, is figure out what the entire payment for a year was. Now we can pick any year, doesn't matter, should come out to the same thing. And then once we know that, we can divide by 12 to get our monthly payment. So I'm going to take just this last year right here, because that's an easy number to work with. So $6,705.73 plus $157.40. So if we add those together, 6705.73 plus 175.40, I get $68,063.13. Okay, so that's how much they pay for the year. So monthly, we're going to have to divide that by 12. And I get $571.92. Now, if you pick any other month to work with, you might get slightly different answer depending on what the principal and interest added together is. They should be very close, though, all within $571 or so. So that's how much the monthly payment is. And then our last part says, what is the total interest over the life of the loan? And there's no easy way to do this except for going through and adding up interest paid for each year. All right, so let's see. It'll take us a while. 3158.45 plus 299, 7.98. Plus 2830.58, 2655.91, 2473, 247.69 plus 2283.58, 2085.20. 1878.24. Let's see. Okay, just when I did this before, I just added the first column up, added up this one, and added them together, just making sure I have that same total right there. So that's the total from the first column. Second column for interest paid, we've got 1662.30, 1437.02. 1201.96, 956.72, 786, 433.88, 157.40. And that's different than what I got the other one. All right, we'll see what we got. All right. Making sure I didn't enter anything wrong in here. 786, 956.72, 201.96. No, that looks all right. Maybe the one I had on my computer or my paper is wrong. So 6550.14. So add that together with the total from the first column. And 26, sorry, $26,913.77 is what I got for my total pay.